Alright, let's now consider the work of a spring force. What would be the equation of the work of a spring? Again, let's start with the fundamental equation. It should be du F er for a vector notation, or F dot ds for a scalar notation. So for some context, let's draw a spring. Say this is a spring with some spring constant K. This is the unstretched length. This is the equilibrium position, meaning there is no resistance from the spring force. So if we pull, or if this elastic spring is elongated in this direction, let's say we apply a force Fa, we stretch it, this we apply Fa, there is a reaction by the spring force. This is the displacement ds. Or if we push the spring, and this is now your ds. Since you apply some force, the resistance of the spring force is again opposite to the applied force and opposite also to the displacement. So what we can notice here is that the spring force is always opposite to its displacement. Therefore, the resulting equation for the spring force alone is negative Ks. The reason for negative is, of course, because the force of the spring is always in opposite direction of the displacement. But of course, the origin of this equation comes from the experimentation, which is Fs is directly proportional with the displacement. So if you introduce a constant, it would be this, and you add a negative sign to include the opposition of the spring force to its displacement. Okay, since spring force is not that complicated as far as its direction is concerned, we're going to use this part of the equation. No need for a complex directional consideration. So let's use this one. This would be F ds, and since our F is equals to negative Ks, so the work of a friction or spring force from point 1 to point 2 is equals to S1 S2 negative Ks ds, or that would be negative K S1 S2 S ds, or negative K S squared 2 from S1 to S2, or that would be negative 1/2 K, that would be S2 squared minus S1 squared. So that is the work of a spring force with linear relationship, because there are other relationship, which is, let's say, example, negative Ks 1/2 or negative Ks to the third. So if the spring force happens to be non-linear, then you have to go from the start to derive a specific equation for that specific spring. So for a recall, the graph of a variable force from displacement or point 1 to point S2, it does vary. So for a work of a constant force from point S1 to point S2, it is constant. For the spring, it is like this: S1, S2. This is the F, this is the F cosine theta, since it is constant, and this is the Fs. And the area under the curve is the quantity of work done. Okay, so for instance, for a small, say ds, and still this is your F. So for a constant, small ds, still this is the F. So for the spring, it varies, but the area under the curve, that is the work. That is the work. But the distance of this, that is equals to Fs/Ks. So that would be all for the work of a spring force. It is negative. Take note of that. It is only negative if you disturb it from its equilibrium position, but if you try to restore it, it will be positive. Because your final position is less than its initial position, then you're trying to restore the system. Then you're trying to restore the spring, because that would be the case where the spring force and displacement are in the same direction. Okay.